Okay, so in the last class, last lecture, we talked about, we finished off the planes, family of planes in different systems, and how the interplanar spacing is. We will move on to hexagonal system. So in case of cube, you can see here now. Or just consider it as a unit cell. We'll come back to cube and distinction with other systems a little later. So you can see that in this system, if this is x, y, and z, this direction is depicted as, what would this direction be if I take this as origin? This would be, this direction would be 1 0 0, because you have intercept of 1 along 1. So this is 1 0 0. So this is 1 0 0. This is 0 1 0, and this is 0 0 1. What is this direction passing between these two? This is 1 1 1, because it's one of this, one of that, and one of that. Okay. If you consider this direction, 1 1 0. Now in direction also you have a concept of negative. Okay. So just like you have, so let's say if I want to draw 1 bar 1 0, then again I need to shift the origin, shift the origin appropriately. So I can see that my one translation along y axis requires me to shift the origin in such a fashion so that I am able to move along negative y axis. So I can now put my origin here. So this is my new origin O prime, and if I go, so if I need to go one along x, which is this, and one along minus y, and if I connect these 2 points, this would be 1 1 bar 0. And in direction you can see that 1 0 0, 2 0 0, 3 0 0 all are same directions. So in case of directions, in case of planes we write 2 0 0 plane, 3 0 0 plane, because they have different spacing. In case of directions, when it's 3 0 0 direction, 4 0 0 direction, you don't write it's 4 0 0 direction, you write it as 1 0 0 direction, because it's a vector. Okay. So they are all represented as as 1 0 0, basically smallest set of integer. Okay. In terms of smallest set of integers. All right. So I'll just do one more example, and before I so let me now draw one direction for so let's say this is AB direction. What is the indices of AB direction? I mean, one thing of course is that you can determine the indices of, you can determine this point is nothing but coordinates of this point are 0 1 1, right. Coordinates of this point are 0 1 1. This origin, I mean this when you work out the coordinates of a point, you always work out with respect to the main origin, which is the this common origin, this is O. So, this is 0 0 0 1 1, and what is the origin of this point? This point, the one in the center, this is half of x and half of z. So, this is half 0 half. So, one way to determine the direction is this is half 0 half minus 0 1 1. So, what do you get at the end? So, basically half minus 1 minus half. So, this is nothing but 1 bar 2 bar 1. Okay. Another way to determine is you just move along the x y directions. So, I can see that I need to go if I take this as a half of x in negative x direction and positive x direction. So, I have moved x intercept as half. Okay. Now, I go along y. So, along y I have moved minus 1, and then along z I have gone minus half. So, my UVW, my direction is half minus 1, and if I multiply this by 2, it will be 1 bar 2. I get the same answer, right? So, you can do it by this fashion, you can do it in this fashion, both are fine. Okay. So, this is how you determine the indices of any direction, which is nothing but a vector, right. So, again for a cube, for cubic system, UVW means family of direction, right. So, 1 0 0 would mean 1 0 0, 0 1 0, 0 0 1 and bar 1 0 0, 0 bar 1 0 and taking the negatives into account. Okay. Similarly, for you can say let us say for 1 2 3 direction, you can have multiple possibilities for 1 2 3. You can have 1 2 3, you can have 1 3 2, you can have 3 2 1, you can have 3 1 2, and so on and so forth. You can keep writing the possibilities and you will reach 48 possibilities, all right. So, similarly to and in tetragonal system again, tetragonal again you have, so 1 0 0 in tetragonal will mean only 1 0 0, 0 1 0, bar 1 0 0 and 0 bar 1 0, and 0 0 1 would mean 0 0 1 and 0 0 bar 1, because these two are, because the translation along those two is different, right. So, they are two different vectors. So, this is the difference between tetragonal and orthorhombic. So, again you can work out the multiplicities by yourself. So, for example, for cubic system your 1 0 0 will have a multiplicity of 6, your 1 1 0 will have a multiplicity of 12, your 1 1 1 will have a multiplicity of 8. So, that is how you draw various directions. So, direction is simpler as compared to plane in the sense of understanding it. Now, there is a special case which is of well, before I go to hexagonal system, another thing that I want to draw to your attention towards is that in some systems we take, so when we want to, let us say we have a plane HKL, okay, the perpendicular to the plane that is a vector, right, or direction, right. So, for cubic system in general, HKL plane normal is direction HKL. So, if you have a plane 1, 2, 3, sorry, so 1, 2, 3 plane normal will be also 1, 2, 3. Okay. So, this is specifically for cubic system, it applies to all the HKL planes, all right. In case of other systems, it may apply to certain planes, it may not apply to certain planes. For example, in case of tetragonal, you can see that 1, 0, 0 plane and 1, 0, 0 direction, they are perpendicular. Okay. So, they are fine. 0, 1, 0 and 0, 1, 0, they are fine. 0, 0, 1 and 0, 0, 1, they are fine, all right. 1, 1, 0 and 1, 1, 0, they are fine, but 1, 0, 1 and 1, 1, 0, sorry, they are not fine. Even 1, 0, 1. So, now, so if you look at one, sorry, that is what I wanted to write actually. What did I write? So, 1, 0, 1 and they are not. Okay. So, when you mix H and L, K and L, when you mix H, K with L, then this normality condition does not hold true, which means the plane normal does not have same Miller indices as the plane, okay, plane normal. The Miller indices of the plane normal are not same as that of a plane when you go to a tetragonal or orthorhombic or other systems, especially when you mix up the Miller indices with the Miller indices corresponding to the dissimilar axis. Okay. Now, what we will do is that we will move on. So, in case of, so we have taken a 3 axis system, this 3 HKL UVW system applies to all the crystal systems. Okay. Applies to, this notation applies to all the crystal classes. In case of a hexagonal system, we can also evolve a new system, which in case of hexagonal. The hexagonal also follows this system, but in case of hexagonal, because of the geometry of hexagonal system, so hexagonal system is something like this. Okay, let me draw how well I can draw. Okay, this is my hexagonal system and this is the, so this is the first one, this is the second one, this is the third one. Oops. Okay. Now, since hexagonal system is not can be represented not only by this individual unit cell which is here. So, this is the individual unit cell, okay. It is not drawn very nicely, but I hope you can see what I am meaning here. So, this is the 1/3 of hexagonal unit cell, which is a single unit cell. Now, this single unit cell can be represented very well by a small unit cell of by the 3 axis system by HKL and UVW. However, what we can do here is the following. If I take this as an axis A1 and this as an axis A2, then there is a third axis in this direction, which is, so this is A1, this is A2, there is this third axis which is called as A3. So, this can be, and of course, the fourth axis remains this one. So, the HKL plane in this case, if I take this four axis systems A1, A2, A3 and C, okay. Normally in hexagonal system we call this as A axis and C axis, okay, because A1 and A2 are equal and they are symmetric. We call both of them as A axis, and the perpendicular one is perpendicular to the basal plane is called as C axis. So, this plane, the base is called as basal plane, okay, basal plane. So, now we can see if we, instead of taking this small unit cell as the hexagonal unit cell, if we take the big unit cell which is the hexagonal cell as the unit cell, then we can conveniently choose a 4 axis system where A1, A2, A3 are 3 axes within the basal plane and C axis is the axis which is out of the basal plane. And you can see that by symmetry A1 and A2, A3 are related to each other. So, you can see that A3 will be nothing but by vectors A1 minus A1 and so A3 will be nothing but, you can see that A1 plus A2 plus A3 is equal to 0, right, because they close each other. So, so basically A3 in some sense will be minus of A1 plus A2. So, we define a new system which is called as, so instead of 3 axis HKL system we take HKIL, where, so this is plane where H plus K is equal to minus of I, but the direction if I have three plane system U, V, W, then that can be written as U, V, T, W, okay, where one can prove it vectorially. Capital U is 2 small u plus small v, capital V is 2 small v plus u, and capital W is equal to small w. So, I am not going to get into the derivation of this. This derivation you can find out in many texts. It is very simple vectorial derivation. So, you can see that U, V, W. So, the plane HKL can be represented as HKIL. So, plane HKL in 3 coordinate system can be represented as HKIL in the 4 coordinate system, where H plus K is equal to minus I. Direction capital U, capital V, capital W can be represented as small u, small v, small t, W, where there is a correlation between all the u's and v's, all right. So, this is one simple representation of hexagonal system. So, what I am going to do now is I am going to give you the knowledge of the system on the basis of some PowerPoint. It is easier to draw there. L becomes HKIL and H plus K is equal to minus I, and direction becomes UVW becomes UVTW. These are the relation between small u and small u, capital U and small v, capital V. So this is the conventional unit cell that we take, and the black one, the big one, is the hexagonal unit cell that you take. So this is your axis A1, this is your axis A2, the third one is A3. So if I take these planes normally, if you took, now remember there are two types of unit cells, one is the smaller set of unit cell, one is a bigger unit cell. So if I look at these unit cell, these planes, the planes marked in red, the first one is 1 0 0 because it is parallel to A2 axis, right. So it's in the 3 coordinate system. If I draw this cell as, this will be 3 coordinate, this face on the right will be, so this face on the right will be 0 1 0 system. You can see the mouse, right. The problem is with this face. How do you face this face as? This face is also a face of another unit cell which is adjacent. So in some sense this is a face which is just like 1 0 0 0 1 0 face, but it can be but basically this face is parallel to this plane in the middle, and if it is this plane, if it is parallel to this plane in the middle, this becomes 1 bar 1 0. So there is a discrepancy. If you rotate the hexagon, this, the one on the left, this 1 bar 1 0 will become 1 0 0. So why is it that it's noted differently? It's denoted differently, right? So that is where 4-axis system helps. 4-axis system will allow us to determine all of these planes in an identical fashion, because now if I convert this into 4-axis system, this 1 0 0 will become H K I L. So H and K will remain same, I will become minus of H plus K, and L will remain same. So this will become 1 0 minus 1 or bar 1 0. Similarly this will become 0 1 bar 1 0, and if you now look at this, what will this become? This will become 1 bar 1 0 0. So now they look fairly identical, that you just juggle around with the HKI indices and L remains the same. So basically they are same family of planes. It is 1 bar 1 0 0, it is 1 0 bar 1 0, it is 0 1 bar 1 0. So they remain same family of planes in 4 coordinate system, and they look like as if they are the same. They are the same family of planes, but in 3 coordinate system you end up having a indices which looks different, okay, which feels different in a hexagonal system, and that is why, to make it easier for one to understand, the 4-axis system is invented. Similarly, now if you draw the, for example, if you now want to draw this 1 1 bar 2 2 plane, okay, let us say I choose the indices 1 1 bar 2 2, okay. So this is it's not, so this is 1 1 bar 2 2 plane. So how do you draw this plane? This is your 1 1 bar 2 2 plane. So you have one intercept on A1, one intercept on A2, half intercept on C. The other one is automatic, because H plus K is equal to I, H plus A is equal to minus I, so that becomes automatic. So if you look at this, it will intercept through half of this length in the opposite direction. This is A3 axis, and you are intersecting at this point, which is half of minus A3. Now let's look at this problem in a slightly different manner. So you know how to draw the plane now. For drawing the planes, it's easier to follow the same convention. It's just that the third will be drawn automatically, okay. If you wanted to draw, for example, 1 bar 1 0 0, so you wanted to draw 1 0 bar 1 0, you have one intercept along this direction, one intercept along minus this direction, and the other ones are parallel. So this is parallel to A2 axis and C2 axis, C axis. So this is 1 0 bar 1, it only has an intercept along A1 and minus A3 axis, nothing else. So now let's try to draw the direction, okay. So in this case, let's say I want to draw a direction 1 2 0. This is a hexagonal basal plane, and I am drawing 1 2 0. 1 2 0 is simple. I go 1 along A1 axis and 2 along A2 axis, and then join with the origin. So, that is what I will do 1, 1, sorry 2, this will be 1 2 0 vector. Now, what will I do if I want to draw in 4 coordinate system? In 4 coordinate system, now if I want to draw 1 bar 1 1 0 plane, this is 1 0 1 bar 1 0 plane, 1 along A2, sorry this is the direction 0 1 bar 1 0 direction. So, this direction will be, so 1 2 0 can be converted into 0 1 bar 1 0, because you know that capital U is equal to 2U plus V, capital V is equal to 2V plus U. So, since so these are capital U, capital V and capital W, you can determine small u, small v, small w, which will come out to be 0 1 bar 1 0. So, to draw this direction, you can see you are at this origin, you go 1 along A2 minus 1 along A3 and you will end up at the same point, right. So, whether you follow a 2 axis system, whether you follow a 3 axis system, you end up with the same direction. If you end up with a different direction, that means something is wrong. Is that clear to you? I have converted it. So, 1 2 0 is equivalent to 0 1 bar 1 0. So, in the first case, this is 1 2 0, 1 along A1, 2 along A2. So, I move from O to A. In the second case, I convert this into 4 axis system. So, now this becomes 1 2 0 becomes 0 1 bar 1 0. So, I do not have to go along A1 now, I have to go 1 along A2. So, I go 1 along A2, I go 1 minus 1 along A3. So, minus 1 is, this is A3. So, this is in opposite direction. So, this is minus 1 along A3. I end up at the same point. I should end up at the same point. If I do not end up at the same point, which means there is some problem in the conversion, alright. So, this is how you draw the direction in 4 coordinate system in hexagonal. Okay. So, in the previous case, I showed you how you draw the plane, the 4 coordinate system, following the 4 coordinate plane, and in the 3 and in this slide I showed you how to draw the direction in 3 coordinate and 4 coordinate system. Okay. So, this is the distinction between, you can do the exercise. So, the home exercise would be for you, which you can do. For example, you can try drawing 1 0 0 plane, 0 1 0 plane. This is in 3 coordinate system, 1 1 0 direction. Let us say 1 1 1 direction, sorry, directions, 1 1 1 directions. This is 3 coordinate system. And in 4 coordinate system, then you convert these into 4 coordinate, system. So, this 1 0 will become 1 0 bar 1 0, this will become 0 1 bar 1 0. You can choose another plane. Let us say I take a plane 1 1 1, 1 1 1 will become 1 1 bar 2 1 plane. So, try doing these conversions and drawing these directions and planes in 3 and 4 coordinate system at home. This will make it clear. Follow the same routine which I have told you in this lecture. Okay. All right. So, we finish it here. So, we have seen that you can describe the unit cells with the use of Miller indices in planes and directions. Directions are nothing but vectors, and which can be drawn very easily and determined very easily. In hexagonal system, because of the symmetry of the unit cell, if you want to represent the unit cell in hexagonal form, you can conveniently choose a system which is you can conveniently choose a notation system which is easier to comprehend for a hexagonal system than for a normal unit cell. So, I can take up little bit more some more problems in the next class on hexagonal system to make it a little bit more clear. Okay. Thank you.